This is going to be a raw footage of a Python introduction. Not planned, no nothing, just going on the fly. So firstly, I'm just going to do it real quick, hopefully. I tend to make super long videos. Excuse me. So firstly, you want to download an editor that you will be comfortable with. So you've got some options like Notepad, if you wanna, Notepad++, which is a pretty good alternative to a text editor in on Windows. Or you've got terminal applications like there's one called Nano if you use Unix-based systems, or NVim, which is more of a advanced terminal-based application. Terminal-based text editor. What I would suggest though is to use Visual Studio Code. So you just go to code.visualstudio.com. This is just a plain text editor on steroids. It's not an IDE, anything that fancy. It's just a text editor, and you can extend it with extensions. So let's say you've got Visual Studio installed, Visual Studio Code I mean. So you want to go to extensions here. My computer would be Control-Shift-X, and you would search Python. So here's all the extensions that you can use for Python, and the fact that you can make yourself for free, it's means there's a lot of stuff here you can use. So I would install the one from Microsoft, which allows you to run Python code on your local machine without using a terminal. So let's say I freshly install Visual Studio. I search Python. Uninstall. Alright, let's say you do that. I'm just going to take another extension as example. And now you want to push the install button. And once that's installed, you're free to go and do some Python stuff. I would also suggest to install the one called AutoDocstring Python Docstring Generator from Niels Werner. This one's pretty nice because it saves you a couple of seconds making documentation text for your functions and even Python scripts. A couple of seconds might not sound like a long time, but you really feel it when you need to do things all the way manually. So now we're ready to start. So I would start with going to File, going to you know what? I would do it this way. So I would first open my file browser. Say, never put your projects on desktop. That's just a no-go. A couple of reasons. I would do it in Documents and just say test project, and never have spaces in your file names. That's pretty important actually, and you'll quickly see why once you start doing Python. So let's say this is my project directory or folder. So I want to right click and open with code. It will open a new instance of code right into your directory. Directory means a folder on your computer. I would right click and say new file. So usually the primary file that a project would have is called main.py or app.py. So it'd be app.py. Which name you choose depends on your background. If you're new, you come from a scripting language background like JavaScript or stuff like that, you would say app.py. But if you come from Java, C, C++, and other older languages, you would use main.py. And that's because in those languages, it requires your main file to be called main.c sometimes. Other times it's because there's a function, which in C it would look like this. So this function is called main, and main is the function that it would be like the starting point. It's kind of like you're going into a house and you're in the hallway. So based on main, you just call your file main.py or main.c, depends on your language. But because you want to do JavaScript or Java and similar scripting languages, we're just going to call ours app.py. So a Python script is really just a script. And why is it called a script? It's because it's meant to be used in a terminal. So before we install Python, because in Windows you don't have Python installed by default, so you would go to search Python and go to downloads and download the latest version. Once that's downloaded, I don't know if you have to restart the computer, I can't remember, but right away you can go to your terminal, or if you don't have Windows 11, open your PowerShell. Never use the CMD, that's old technology, you don't really want to use it. So you can start by checking if you have Python installed by saying Python space -v, and you'll see a bunch of stuff here. I wonder if it's let's see. So when I did that, you see I ended up with at the bottom here a greater than signs, triple greater than signs. That means you're in a prompt. I wasn't supposed to be here, so I press Control Z to access this prompt, and CLS to clear my terminal. Now when I do Python version, there you go, you'll see Python 3.11.0, at least on my Python version. Now if you just press type Python, you'll get this prompt here. Prompt means it's a message from the terminal and it waits for input from you. So usually indicated by greater than signs or triple than greater than signs. And now you can start writing Python. So what I would normally do is use this as a calculator. 3 plus 3 is 6. Say 9 plus 1 is 10. So let's start from here and move on to Visual Studio Code in a little bit. So we start with the basics. That's me doing unscripted videos, like I always do. Alright, say you have a let's say you have a math assignment, and or you have some kind of problem which says, just dead simple primary school tasks. You have 3 apples, and you have 3 apples. Your sister has 9, and your parents together has 5. How many do you have in total? You would say 17, right? 3 plus 9 is 12. 12 plus 5 is 17. And then you would say, alright, now in a week, the amount of apples you guys have will be doubled. So what you would say normally is, if you use algebra, 2 times, in parentheses, 3 plus 9 plus 5 equals hopefully 34. And the reason is because of order of operation. So you would expect that what's in the brackets will be computed first, so that would be 17, and then now that we've solved the ones in the bracket, we can multiply it by 2. That will be 34, and we get 34. Now that's all good and fine, but ideally we would want to be using this number several times. So it's kind of abundant to always type 3 times 9 plus 5. So what we could do is assign them to variables. Now variables in the computing is very much like variables in maths, just more flexible. So let's say we have a variable called total. We're gonna call it 3 plus 9 plus 5. So we're gonna assign 17 to this variable called total. Now you don't really get anything from this, but behind the scenes, total will be saved in your memory or your RAM, which stands for random access memory. I'll just type this like this. And random access memory is usually what the kind of memory that you as a Python or JavaScript programmer would care about. So if we want to see what's in our total variable, we would say just total, get 17. Let's say you want to add multiply by 2 like we did earlier. Total multiplied by 2, you get 34. And you can go on and on about it. Times 2 would be 68. Times 2 would be 136. You can even assign that to another variable, bigger, total equals total times 2 times 2 times 2. And you can write out bigger total to be 136. Now what you can see here is we started with adding numbers together, just regular basic arithmetic, and we can use brackets to change the order of operations, because if you didn't have this, 2 times 3 plus 5 plus 9 plus 5, if you didn't have the brackets, it would, because of order of operations, mathematics, you would have 2 times 3, and then you would have 6 plus 9 plus 5. You get 20, and that's a different result than we want. So now we covered basic arithmetic. Basic arithmetic, and we have covered variable and assigning variables to new variables. So let's talk a little bit about variables. Actually, first, that pound sign or hashtag is called a comment. The cool thing about comments is whatever you type after the hashtags, it will not be computed. So for instance, you have 2 plus 3 is 6, but if you put a hashtag on it, it will be a comment and you wouldn't get anything from it, which is pretty handy. You can tell people what you've done. Let's say you say 2 plus 3, that means nothing, but if you say we add numbers together, then you say 2 plus 3. That would explain to other programmers what you have done. So let's talk a little bit about variables. Now you see that when we assign assign data to a variable in Python, let's say you have age. You can say, for instance, for me, 25. We have a number and we assign it to a variable, and we have another variable called name. We say Kai, and we can have true and false Boolean expressions, which is either 1 or 0 or true or false. You can look it up. Let's say is male equals true, is female equals false. Now what happens if you type incorrectly? Is female with lowercase f? You'll get an error. So for Booleans, it's either true or false with uppercase F. And for text like this, which is called string, it's always surrounded by quotes. Say some text, or with single quotes, which is also valid. So that's the essential of just programming in general. So let's take a look at where Visual Studio Code comes in. So you see now we have a very unorganized environment where we've written code, and it's just all over the place. It's quite hard to read because you have all these prompts here. You have comments that make no sense. You have lots of white space here. And if you want to share this code, it's not going to work because it's on your terminal. If you leave this prompt with Control-Z, and then you close it, now we open our terminal again by Python. It's all gone. You can't even press the up arrow to type your previous commands from the history. So that's not going to work. So this is where Python scripts come in, the Python files. You can write code and reuse them later, and you can even make libraries and modules so you can reuse code and share with the world. So let's take a look at that. So now that I have a file, I can actually share it with you once I finish this tutorial. Let's go through variables again, because it's pretty essential to know. We have something called, you know what, let's do a multi-line. So multi-line comments are made with triple quotes like this. So let's use the multi line comments to underline what topic we're talking about, and then we use the regular hashtag to as a sub comment or subtitle, if you will. Let's look at integers, or just int, which you will call in most languages and computer science general. So integers means whole numbers without decimals. So let's say my first number would be 1, my second number would be 67, and so on and so forth. And now you've got floating point numbers, or as people usually call it, floats. And these are numbers with decimals. Decimals as in 3 point and the numbers behind the points. My float, for instance, would be, actually, say pi would be 3.14556, or golden ratio. I don't even know what the golden ratio is. I say it's pi divided by 3. Let's see. There, it's a little larger text. The cool thing about floating point numbers, or floats, are if you divide two numbers by each other, let's say divide by 2. You can divide a whole number, for instance 9 divided by 2, and you know obviously that would result in 4.5. So in some languages this wouldn't work, because you have two whole numbers, they're integers, and you can't really get floats from such operations. So normally languages would round up the result. So 9 divided by 2 would be 5. Or actually, I think it rounds, it does a floor operation. Round down. Floor means to round to the lowest, closest whole number. So it would be 4. And it's simply because the result would be 5, but you cut out the numbers after the dot. So you cut out this, you get 4. And then you've got bools, or booleans. For instance, is male would be true. You see on Visual Studio Code with syntax highlighting, you get a special, like a dark color if it's true. Is female equals false, and the same with false. This means that true and false are actually built-in keywords in Python. Now let's talk about bools. So with bools, the cool part about something being true or something being false is you can compare two statements and do something with them, whether they're true or whether they're false. So, and printing to screen. So let me show you how that works, and also how we can start utilizing some kind of a user interface. In our case, it would be easier with the terminal. I open this by saying Control, Shift, and I don't know what it would be on your keyboard. Semicolon. I've got like a Norwegian keyboard layout, so it's a little shortcut's a little different for me. So let's say we know that Ismail equals true. Now, when we're comparing something, usually we would use something called if statements. If statements is like in our natural language. If something is true, then we'll do this. Else if something is false, then we'll do that. Otherwise, or else, we'll just do something random. So let's do just if and else to begin with. If Ismail, we want to print out to the screen, actually, like so. How do you say print? So you say print and normal parentheses and a quote or double quote, up to you. I am male. Else you say print I am female. The structure of if statements are, you start with an if, and then you have, actually you don't have brackets, sorry. You start with an if, and then you have the expression. Expression is just some kind of sentence that will be computed. So for us, it would be Ismail, and if that's true, we would say I'm male. Otherwise, we would say I'm a female. Now, important here is after you say colon here, you have to have either tab or 2 or 4 spaces. In Visual Studio Code, you can use tab, and it will automatically convert to space in most cases. You have to choose either tab or space, because Python for some reason is pretty naughty about it. Now, if we want to run this program just to test out how it looks, we would say run Python file on the upper right corner, and open a new terminal first and execute our program with the Python interpreter. Interpreter is a language that will read your code, it'll parse it, and in Python's case, it will make it to something called bytecode, which is zeros and ones that your computer can read. So it'll run the interpreter on your file, which is right here, and print out I am male. Now you see on our regular terminal, we would say something like Ismail. Ismail equals true, and then we can just say Ismail, and we'll get true. Now you probably noticed that executing this program would only yield I am male, which we get from the print statement here. While with all these other variables, we didn't get anything at all. And that's because when you write with in a file and use that as a script, you really want to use this as if it's just a regular computer program. So you use a lot of variables, and you mostly don't want to see them printed on the screen. Otherwise, it's just going to make a whole mess and cause a lot of performance issues. And that's why we use print to just make your program much cleaner. Let's say we are not male, so we say false here. So if this is false, then in theory, let's just say true here, we will get printed I am female, and lo and behold, we have I am female. So those are the variables: integers, floats, and bools. And we also have strings. So let's say we want to make a text that we can reuse later. Technically you have some other variables too, but these are the most important ones in Python. Male text, and then we can have one for female, and we can replace the ones in the print function with the variables themselves. And we've played the game, you can say, run the program, we'll get the same results. The cool part now is we have stored them in variables in memory, so you can reuse them later. Alright, let's move on to functions. So normally functions are a topic you would learn, say if you go to school, you would learn it the second or the third week of programming, but we're just going to go straight away. Functions are like a black box. Now it's kind of like a black box on aircrafts. You get, going into this, you get a recorded audio. So in case of accidents and authorities find the wreck of your aircraft, they can listen to your black box to try to recall what happened before, during, and after the accident. So here you will get, please don't crash there, black box, audio, input, and going out of here, let's say this is the pilots being recorded, and going out here you get the authorities getting audio of what happened. Audio out. In our terminology, the black box is a function, and this is an argument, and this is the return value. These are very, very important keywords that you need to know, but you'll get the hang of it eventually. So a function is some kind of a thing that takes an input and does something with it and spits it out again. It's kind of like, let's say, a food blender. So for instance with this, oh god, fine. So let's say you've got spinach, you've got avocado, you maybe have some butter, and then you mix it up. So your avocado, your whatever ingredients would be your input, and you've got this blender, which is the black box or the function, and it does some stuff like it tears the ingredients apart, it blends them, it mushes them, and then it turns into a soup or a smoothie or whatever you're cooking, and that's exactly the output. You take off the container, take off the lid, and you get the output, the result of the blending process or the function. So if we want to implement this, let's do, I don't know if I have this program. Yeah, I do. Put that here. Perfect. So if we want to make a function like this, let's call it blender. You know what? Let's grab our image here. because the best references you can get are images. We would start with making our blender by saying def, and then that means define, and then we would write our blender's name or the function's name. We call it blender, and then we would have a parentheses where we would state the inputs. So in our case it would be ingredients. Let's say it's ingredient 1, ingredient 2, and ingredient. You know what? Do this. Ingredients 3. Now you see ingredients kind of a lot to type out. So let's just call it I1, I2, and I3, and colon. Now we've got defining a function, a black box. In our case, we're going to define a blender, and we got the ingredients, and now we want outputs. The output is declared as return. So let's start with making a variable for our output. So let's make it an empty string. So what we're going to do with this, so when we want to blend, we kind of want to know what we're blending. So let's specify what we're blending to begin with, and we are outside of this function. We're going to say now we're actually going to write the whole name, ingredient 1, ingredient 2, and ingredient 3. We're going to give this comment and say we are prepping our lunch for today. Our first ingredient, let's say it's spinach. Suppose that's how you type it out. The second one is avocado. Third one is going to be water. And then we are going to get our lunch, which is going to be the result of our blending process, which we just say blender, and then we type in our 3 ingredients. Ingredient 1, ingredient 2, ingredient 3. And I do this quickly by just typing out the beginning of the word ingredient, and then it'll look in your script and see what variables they have that that matches the current input, which are these 3 ingredients. So you see, we have in our blender we call these parameters when we are defining a function. Defining means you are making the recipes and you define the recipe. So we got first ingredient, second ingredient, and third ingredient, and you see it matches exactly the ingredients, number of ingredients we have down below here. Ingredient 1, 2, and 3. So let's say that we pretend like the machine is blending our food, and we turn all the ingredients into, I know, a smoothie. And then out of this blending process we get our smoothie, which is our output. So the the theory is, this is our program. It's got this recipe, which is the blending process, and this blending process is 3 ingredients: I1, I2, and I3. And then we, outside of this blending process, let's say we are in the kitchen, we grab our first ingredient, our second ingredient, and our third ingredient, the spinach, avocado, and water, from our fridge and our faucet, and then we blend them all together, and then we save the output of this in Lunch. Okay, and you can pause this video and think about this. If we play this, if we start this program now, what do you think the output of this process will be? After you comment out these lines here, we don't need them anymore. So pause the video and think what we get. Alright, I'm gonna play and we'll see what we get. Absolutely freaking nothing. And that's because we may have our ingredients here and we may have the result here, but there's nothing actually printing out our stuff to the terminal. So what we could do is say print our lunch is, so here's our string, and then we can concatenate variables to the string by saying plus lunch. You get, remember space there. Our lunch is smoothie. Should be a smoothie. Our lunch is a smoothie. Cool. But you see here in the function, we didn't really do much with these three parameters here. Now when we apply these parameters, we call them arguments. So we got 3 arguments here we didn't do much about. So what we could say is, where we pretend to be blending them, we could say blender is smooshing up the following ingredients. And then we go to a new line and we say I1 plus I2 plus I3. Now this looks a bit weird because these aren't actually numbers. How do you plus them together? Well, you turn them in the background, it'll turn these variables into text, and then we can concatenate, or we can put the text together into one larger text, which is called string concatenation. Now if we play this program, you'll see it says blender is smooshing up the following ingredients: spinach, avocado, and water. Our lunch is a smoothie. Here's the weird one. These are all in one word. You could, for instance, put empty space between like this. And it'll work, but you quickly see if you were to do this for every single variable you get, it's going to be pretty tedious. So there's something called a formatted string, F for formatted. And now if we print this out, it would just be I1, I2, and I3, because these variables are within quotes, and they themselves would be considered as strings and nothing else, not in variables. But we can turn them into variables in this format. Because we have this F here, we can put curly brackets and remove these plus signs, like so. You're just gonna have to pause the video to catch up with what I'm doing here. Now this looks maybe a little cryptic, but if you're familiar with coding from HTML or something like that with JavaScript, these kind of looks like placeholders. It's kind of like you have a form, and let's say this is first name, and then very often there would be a placeholder text, for instance John, with a grayed out color, which kind of would tell you that this is a placeholder. You can write whatever in it. And formal strings are like that. You can say ingredient list, and these variables would act as placeholders for whatever variables are in there. So for us it would be spinach, avocado, and water. You can even change these variables here. Instead of spinach, you can say integer or float, 98.6275, or a boolean, and they would be interpreted as variables, as they are. So now we have learned to make a function, which in our case is Blender. We've learned about parameters. We learned about variables again. We've been revising variables again. We're revising on the print statement again. The statement is kind of like having a function and telling it to do something. Here's our statement, do it. And then we learned about formatted strings, which is kind of like strings with variables as placeholders. And we learned about returning variables, which we have our output here, and then we return out a function. So return is basically you have something inside the function and you want to give it out to people who use your function. So let's do another function here. Let's comment out all of this code so we don't see them in our output again. So I just pressed Ctrl X to directly cut out a whole line. Say we have add, which is just a very basic example. Add two numbers, and 1 and 2. You've got and you want to return and directly and 1 plus and 2, and then you can print 2 plus 3 equals 2. We can use formatted strings here. I actually prefer using that because it makes the code pretty clean. Add 2, 3. So you can, instead of just having variables in here as placeholders, you can put entire functions, function calls here, and it'll print out the results. 2 plus 3 equals 5. Okay, so to sum up, so far, I think it's been an hour now, we've revised on how to download Visual Studio Code, which is go to code.visualstudio.com, and we've talked about the installing Python. We've talked about the terminal, which for most people will be pretty scary, but it's really not scary at all. Instead of typing, using this calculator, 2 plus 3, and then you want to, use that result later, but you have to type the entire expression, just use Python. Open your terminal, type Python. You can make an expression like this, and you get the result. You can even say what is 34% of 308. So you would say 308 times 0.34, you get the result. So that's the terminal and the Python prompt. And then we talked about actually, instead of using a terminal, we can write scripts and just store the whole code in a file for later reuse. So we learned about variables, whereas we've got integers, we got floating point numbers or floats, we got booleans or bools, and we got strings. And you may wonder, well, Kai, if strings is a collection of multiple characters and signs, what's the data type, which is what's the type of variables for a single character? Well, I'm glad you asked, even though you may not. It's called a char or a char. My char, for instance, is a. And most compiled languages like C and C++ and Java, you would specify a char with just single quotes and a string with double quotes. But in languages like Python, it doesn't matter. Just stick with one. Be consistent about it. We talked about functions. For instance, our Blender. We talked about parameters. We talked about returning variables and expressions. Expression here, out of the function. We talked about how to use the function. We got a number of variables we want to use as input. Here's the input. We call the function, which is just the name of the function, and parentheses. And we can assign, if we want to, if the function has a return value, which means it returns something, we can assign it to a variable, and then we can print out the variable. That's a lot of stuff all in one go. So just take your time, go through the video, and just repeat the stuff again for yourself. Another very, very, very important thing about Python is modules. So, I think, let's see, what more modules are there? Python modules. Popular Python modules. Let's see. Python built in Python modules. Here's one. Sys. Let's say this is an advanced feature, but it's actually very important. So let's say we make a new Python script. We call it system dot app2.py. So you see, when in our terminal we want to check if Python was installed properly in our system. We say Python -- version. We get this result here. And then you say, okay, but how do you program that? Because when you just say Python, we get this prompt here. So if this flag alters and changes the way the Python program itself works, then how do we go about making it ourselves? So if we say Python help, you get all the list of commands that this program can handle. So we got something. Let's see. I need to remind myself about a sys.argv. We got something called argv. So this is what the documentation says. So to import a module in Python, you would say import sys. So if the module is named sys, we can import it by saying module import. Now we get the entire sys library into our program. So let's say you want to quit the program and say you've got a variable called and 1 equals 3 and 2 equals 5, you can print out and 1 and you can print out and 2. Cool. Now for some testing reasons, you want to just stop the program right there and then. There's a couple of ways to do it, but if you want to use the sys library, which is built in to the program, I mean the language, you can just say sys.exit and brackets, and you see the print statement here on line 11 will be kind of grayed out. Now it'll only say 3, and it'll cut out the 5 here, and you can say whatever down here, and this is a test, and it'll just not execute this line here. But if you move this line here up a bit above the exit statement by holding Alt, using the up arrow, you'll get 3, and this is a test. There's a lot of stuff in sys. You can even hold Control and press on the sys keyword to get the whole file for the sys module. And this thing here itself is just a collection of all the stuff that you can use. So it's not even the entire library itself. It's huge. So let's talk about argv. So let's say you want to make a program that prints out the version of the applications that you're writing. So let's say my application's name, let's change this file to something useful. Let's make a program that's called timetable. And when we deploy this program here, we want to make sure that the systems we use are up to date and are using the latest version of our timetable scripts. So ideally we would say timetable.py minus version, and we would get the version number of the script here. But what we get now is nothing. Actually, before you do that, to execute the Python script, you would say Python, and then you would say the location of the script. In our case, we dot and / timetable.py. So that's our script. But we want to alter the behavior. So if we say version -- version, we get the version number and not these things here. It would be something like print version 3. Let's say it's 1.0.45. Exit. This is what we want to do. Version 1.0.45. Now it's kind of involved to do this, and there's many ways. There's even separate libraries to perform this kind of task. But what you could do is utilize functions as a group of code that you want to execute depending on the command line flags that the user gives to your program. So let's say we call version a flag. So we would say, let's say we have a function called version, and up here we have a constant. Constant is not a variable, it's data that doesn't change. We can declare these constants with just using all uppercase variable names or constant names. Let's say version, and we say it's 1.0.45. This will be a string. So what this function would do is print out this number here. So we would say print f string version. If we execute this program, we get nothing. But if we call it, You get the version number. None. Oh, of course. Version. Because the function itself prints out the version. There you go, version. But we want to call this from the command line arguments. So what do? We can use, instead of importing the entire sys library, we can use from sys import argv. So we're only importing the argv module of our sys library, or argv function it will be. We can say, let's just for fun print out argv. See what we get. We get this in some kind of weird, what's it called? What kind of bracket is that? You know what? I'm gonna find out. Different types of brackets. Oh, square brackets. Alright, we'll go through what these square brackets mean. Let's say we wanna write to our program version, and then we get in these square brackets we get apparently what's our file location, actually, a comma, and version in these brackets here. Let's do another one. Let's make a program that can have the help flag to print out all the commands that's available to the program. We get the file path and help. We can even have another argument, which would be, say, we have a command called create events for our timetable. Then we get help, and then we get create events. This is interesting. So we just enter these two, but we also get the file name, and that's because for all command line arguments, the first argument is always the file or the command itself. And there's a couple of reasons why you would do this. For instance, you would say if this file name, if you have altered this file in some way or another with soft linking and stuff, hard linking, the program can detect this, and as a safety measure prevent you from using the program, because it might hurt your computer actually. Another reason why you do this is, for instance, if you're creating some kind of malware and you're doing malware analysis, you wanna, let's say you wanna fuck up all Python script, other Python scripts. So you wanna include all files in this computer that is not this script. So you can use this to recognize who you are, who the script is, and not overwrite and or not fuck yourself up. So let's say we wanna get just the first argument. So we would use a notation which is square bracket and 0. We get this out. Actually, let's do to clear screen. When we run, we would say print CLS. Yeah. Python, how to execute CLI commands. Run. OS the system. Here's another module, OS. From OS, import system, I think it was. We can say system CLS, which will clear our screen. Lovely. So now we can print out, if you remember, we can specify all the arguments in our file here. Help, create events. We get the list of all the arguments we gave the program. We can, let's say we will just want to have the file path. We can say file path, and we get this. This file path is such and such and such. We want to say, let's say our first argument of this program is, it should be help, right? So we say 1, and we get help. We say 2, we get create events. Now why is that when we say number 2 here, we get the third argument in this list here? There. There you go. Why is that when we say, there you go. Oh, come on. If you remember, we said number 2 here to get the third element. So why is that we say number 2 to get third, and number 1 to get the second, and number 0 to get the first? And that's because in computer science, we always start with number 0. And normal, when we count stuff in real life, we would say 1, 2, 3, 4, 5. I have 5 apples. We say 1, 2, 5. When computers always start with 0. 1, 2, 3, 4. So it's basically a n-1 relationship. N would be the real number. Computers will be n-1. So let's say we want to have the first argument, which would be help. And then we can use this to determine what is our program going to do. So we could, for instance, store the flag, let's call it flag, as it would be argv, it would be 1. So now if we print a flag, we would get help. And now if you recall, with variables, we store the result of this in a variable, and now we can do stuff with this. For instance, we can use an if statement to check, is flag equals to help? If it is help, we can do stuff with it. We can have, for instance, a function called usage, which will print all commands in this script. We can have past, just have an empty function. Sorry. If flag equals, we use equals check to compare two values of each other. If it is equals to help, then we can call the usage function. So let's say, let's just have usage, let's say time. We can actually say use, this is pretty advanced, but if you just rewind the video and see what I've done, you can kind of get the feel what I do, and then you can start researching to understand more about this. It's just a really rough overview. We can use multi-line string with an f multi-line string, and let's say file path equals argv 0. So it would be file path, and then for instance help, script program that manages the the company's timetable for work shifts, and then you can say commands, and let's say we have our help command, which is this page, and then we have version, which is version number, and then if we call our program with the help flag, oh, of course, we have to print out the variable. Print out. We get this. This kind of looks like the help Python, which has usage, and then the program itself, and then what options you can use, and then all the flags that are here. For instance, -v, Python -V would be the version number here. Print the Python version number and exit. So we can use print the timetable version number and exit. And you notice I didn't press any save buttons or anything. It just did auto saved for me. You can do that by going to file and then auto save here. So let's say you want to print out the version number. We could say instead of just if and else, we have if, and then if it doesn't match the help string, we can say else if. Then we check another condition. Flag, I think it's actually called elif in Python. Flag equals version. Then we got version. So now our program can print out the help page or version number. Pretty handy, huh? And then you can, for instance, say else. We just for fun, we're gonna print out this. We're gonna add the second and the third parameters together. We can say print argv1 plus argv2. This might not actually work, and you'll see why. 2 and 3. That's weird, isn't it? 2 and 3, and we add them together, we should get 5. But instead we got 23. But if you remember, it's because string and string becomes a larger string along the string or along the text. And you can see here, if we hover our mouse here, it says list, whatever that is, and the string. So if we look at the form, list would be this, and then brackets there. String would be whatever is in here, and that's a bracket again. So we can kind of assume this is a list of some sort, and this actually signifies there's strings in the list, and that means this arg is a list, a collection of strings. Let's quickly go over what a list is. A list is a collection of things. Let's make our list. My list. I think you have to use a curly bracket. You can say apple, orange, bananas. We can try to print out this list here. print my list. Cool. Pretend like that didn't happen. There's a reason why it didn't happen. I'll tell you in a second. Or in a minute. So, this is a strange one. Did I do something wrong? Should it be square brackets? Apple. Wait, no. Let's see. Python list. My list, Apple. Oh, you need commas, of course. Okay. We got apple, we got orange, we got bananas. So list is a collection of things. It could even be variables. I think you can actually mix numbers in here, I'm sure. Yeah, you can even mix different types of data into the list here. So let's say instead of just making it that ugly, we want to say I don't want this. This is kind of distracting. My list of fruits. So we can say my list of fruits. So ideally, I want to print out my fruits on each line, with like the dash markers to kind of signify this is a list of things. So I could say print my list, and we're going to get the first element in my list. Print my list, which is the second element, and we can copy and paste, which just Control C and Control B right away, and we can get the third element. This is fine, but let's say we have 100 elements. This would be pretty tedious to type it all out manually. We got something called loops. So we got different loops. We got while loops, for loops, and for each loop. And we also have in other languages something called do while loop. There's quite a few you can use. Ranged base, which is kind of the same as for each. So what loops are you're iterating, which means you're going one by one over a list of things. For instance, we want to go over the things in our list here. So let's say I want to one by one go over apple, orange, and banana. We can use for. Let's give a variable name to our fruits. Let's say f. In our list of fruits would be my list. Now the cool thing is you can just, for instance, let's say we have a counter. We can say for each element in our list we can print the counter, and we can increase the counter by 1. And when we play this, we get apple, orange, banana from these, and 0, 1, 2, which is perfect. So instead of counter, we can print out f. Let me move this line here, and we should get apple, orange, banana. So we don't need these anymore. It will just print out all the things in my list. So we can say guava, avocado, and it will also print out these items here. We can even this, if we have 100 things here, it's going to be pretty long. We can even put them in separate lines, and that's perfectly legal. Now it might be a little more readable. Apple, orange, banana, guava, avocado. We can even say have this minus sign here, \t, which is special character I'll talk about right now, and we can mark this and say square bracket to automatically put square bracket around the F here. So what's \t? Without it, it becomes this, but with it, it becomes this. \t is a special character called escape character. Escape because you have the backslash here, and instead of just printing out just t, you do backslash. It interprets to be a special character. In our case, that's a tab. You also got something called \n, escape n, which is a new line. So it'll print a new line for every single word. Print has a argument called AND. If you do AND, which is the last character in the print statement, then you can manually type out \n for yourself. If you don't have that, it becomes all a one-liner. Okay. Now, why am I talking about this? And I am going off track for what we talked about the argv and stuff, and writing an actual functional application, is because this list here is pretty handy for instance, listing up all the arguments we can have in our program. Let's say our timetable program, let's say all available commands, we want a version command, help, create, and create event. We want delete event, and we want to see details, for instance. And you see here we have a list of events, and we have events on this side, and then we have the description on this side. What if we have two lists? One is for the command itself, and one is for the descriptions. And then we could just manually type tab between these two. So here's our commands, and then we can have descriptions. For the first one, it could be, let's just copy these. And the second one would be this page. Create a new event, delete an existing event, and see more details about an event. Cool thing is, if you want to have a scalable program, these don't have to be hard-coded in our program. We can even have a separate text files that's super easy to edit by non-programmers. Even your grandma can do it, or great-grandma if she knows computers. And then they can write all the text, and you as a programmer can interpret the text and put it into your own program, which is extremely powerful. And that's how you basically configure Minecraft servers. You have this JSON or this XML file, and it's got some special syntaxes that your program knows the rules of, and it can parse, interpret that JSON file, and get those settings for the Minecraft mod from the page. And this is how you can do it. So imagine this is like the stuff in the JSON file. And then down here you're interpreting the code from JSON file. So here, when we, instead of writing out the commands and the descriptions manually, we can say we print out this part here, and then we can have a for loop. Let's have a counter here. Let's call it I. While I is less than the length of commands. We have 1, 2, 3, 4, 5 elements. I think you can say commands dot run. You know what? Let's see what this gives us. Print. We're gonna say help. Okay, like this. Cool. 5. See it down here. So we can say a while loop is we do something while this expression is true. So if you say while true, this is an infinite loop. It's always true. But if you say while I is less than the length of our commands list, then we could, for instance, just print out I, just to double check. It's always 0 because that's why we double check, right? We forgot to add I plus 1. 0, 1, 2, 2, 3, 4. This is special syntax. Why is I equals to itself? Because it computes the expression from right to left. So 1 plus I equals to a new I. So now we can say, we can for instance print out the element in commands by the index. Oh. There. So now we have, I hope it's not too little. We have there it is. Our power page, here's the text, here's the commands. We can even have this as a f string, so we can put text in the argument itself. Let's do this. And have the \t, and yeah, and we print out. This is a little awkward. Let's open this as in a new terminal. Python timetable help. So cool. By just adding stuff, to our list of commands, we can even say, let's say add new user, and we can say here add new user to the database, and it'll automatically add a new command here for us. Pretty handy. We as a programmer don't care about what command it is, it's up to the user. And then, but we also want to print out the description. So we know that the description is going to be the same line as the command. So we need to use the AND argument here to specify we don't want any new characters added automatically to our strings. So if we print out the help now, we oh, that's fine actually. Here. Now it's all on the same line. Perfect. So what we could do now is we can also print just to make it more visual in our code, we can print on the same line here with the semicolon. Actually, no, let's not do that. Print f, we can have two of these \t descriptions bracket I, and we do want a end here, automatic new line. And now if we print out the commands, we get this. We can even make 30 so we don't get this awkward thing here. No, okay. Guess it does not. Ready? No. That's fine. It almost works. Almost perfect. But it's good enough for our purpose. So yeah, we have dynamically said what our file name is. We can even change that. Instead of timetable, we just say time. Time. And then we have dynamically stated what our commands are and the description of commands. We even have version. Get the version number. We can we delete the command that adds two numbers together. It's complaining about time. It's quite a timetable. Cool. So now we got a program. It's actually a not complete program, but it's a program. It works like command line program. You can print out the help page. And you can print out the version number. Time. Table. Now you can do really cool stuff with Python. For instance, you can start communicating with your computer itself. You saw I used system, and then I could enter the command that I would use in a command line. So for instance, you've got this thing called ipconfig on Windows, which will print up all the IP addresses of your computer. And don't worry, this is not public IP addresses, it's just local addresses. Everybody's got this address here, so don't worry. So I would say elif flag equals, for instance, IP. I would say system ipconfig, which is exactly what I typed here. And now if I say --IP, I get the same thing here. I can even say elif flag equals ping. I can choose to ping a website of my choice. So I could say system, let's say that we have a variable that specifies what website we're going to ping. We call it address, which would be arg2. So now we can ping google.com. We can ping twitter.com, and we can even ping bbc.co.uk. pretty useful stuff. You can even ping yourself. You can say localhost and you ping yourself. So you can see we went from doing mathematics, just simple arithmetic. We started with functions, and now 2 hours in, we're at the point where we can make fully functional programs with a little bit extra stuff like lists, just to make things easier for us, with constants, with calling system command lines, commands. And we even have this argv function from the sys module that lets us fetch user arguments from the command line terminal. And we use these things to dynamically generate our help page. We can even have this version number in a separate file, so JSON file. So let's say we have for instance, it looks, I'm sure you're familiar with this since we talked about JSON already. We've got a key called version. You can say it's 1.0.45 string, and then we have commands. It says this lowercase version, and we can have an array, which is like a list. It's a different name list of commands version. We can actually copy this. I think you have to. Yeah, that might work, I think. And then you can have descriptions. I think this is valid as JSON syntax. So this is how it would look like in a JSON file, and we can use a library to fetch these keys and use them in our program. It's pretty easy actually. And then we went from using argv to pass the user command arguments from the command line to doing useful stuff that actually can make a difference for us. We can interact with the computer by saying ipconfig, and we get this. We have a command that we can see IP addresses. We even have a command that we can check our connection to websites and even to ourselves. With Python we can also fetch all the lines that has IP addresses and cut out all the white spaces and all the stuff that are irrelevant to us, which is pretty nifty. We can also only fetch stuff from this section, for instance, with a little bit of magic, with string magic, or we can just fetch the ones from here, from WSL. So there's lots of things you can do. So you can even create a web server with this. You can even create Discord bots and anything really. And let's say you want to work with JavaScript now that you know about Python. So how can I convert my Python skills to JavaScript? Well, it's pretty easy. For instance, we can start with saying variables. Let's say we have a string, fruit. So instead of just saying fruit, we have to say let apple, and we can say my number equals 1. In JavaScript we use semicolons actually. It's just a syntax thing. We can say my float equals 3.56. Actually, that would be pi. And then, for instance, a function, it will be function. Function add. Yeah, 2 numbers, and 1 and 2. And instead of colon, you will have a curly bracket. You would say return, like in Python, and 1 plus and 2. Semicolon. And then you can use the print command in JavaScript. It will be console.log. Let's say 3 plus 4 equals to, but there's no formal strings in JavaScript, so you would just have to use the plus notation. 3, 4. You can say no. So on left you have Python. Let's say it will be this one. So here's Python variables, and here's JavaScript, and here's a function. Let's use this here. Here's the function, the add function, and there's the add function in JavaScript. So they're pretty similar in almost all the ways, and you can use formal strings, or you can just plus them together here, as you see here. So why do I say you should learn Python before you learn JavaScript? It's because in JavaScript you've got stuff like semicolons, you've got the color brackets. They're not strict about the indentations, so code can quickly become unreadable. You also got stuff like anonymous functions that you see all the time. For instance, we can, instead of saying function myfunc, you can assign functions to variables. Myfunc, we're saying let equals to function. So that's one way of doing it. So here are the function parameters, and1 and 2, and you can say return and1 plus and2, and you can call the function myfunc 3, 4. These two are exactly the same. They do the same thing. It's just different notations. There's even worse. There is anonymous functions. They also call it arrow functions. Let's say myfunc2 equals no function keyword. You have an arrow, and then you've got the square bracket, the color brackets there. You see this function, you don't even need a name for this function, and here are all of your parameters. You can do something like this with arithmetics, like you have a variable, say my big number equals 3 plus an arrow function here. Let's say you have two variables, let and 1 and n2, and 1 equals 3 and 2 equals 4, and that will be n1 and 2, and you can say n2 minus n1. So you can have an expression without a name inside an expression. I think you have to do this. So you even have to have a bracket to specify this thing is an expression. Using a bracket here signifies this by itself as an expression here. This is needed. So inside a bracket, the parentheses, we have a new parentheses with the parameters we want for this function without name, and then we have the return value here. So n minus 2 will be plus by 3. Very, very difficult, I would say, for beginners to understand, because it's just so unreadable. It would be much easier if you just declared and defined the variables separately and beforehand, and then used it in your expression. So that's why I would say start with Python and then go to JavaScript later. Minecraft is Java. It's powered by Java. So similarly to this, we can create a new file. We call it main.java. Java has usually a namespace. Main. Let's see. Does it? I think it's just def main. Let's say this is the main function. And then, is it? Java functions. Going crazy here. Oh, you need a class. Right. So Java is object-oriented program. So I haven't talked about it. I'm not going to. It's a class. It's basically just a collection of things. The class has a function. Let's call it main. And then inside this function, we can do stuff. For instance, we can declare variables. If it's a string, we can say string fruit equals apple, semicolon, int number, because it's an integer, we have to specify it's an integer, equals 1. We also have to specify it's a float, and it's a special way of doing it actually, equals 3.14156 f. Its f is important there, because otherwise it's not longer a float, it's a double, it's a different kind of decimal floating point number. And we can specify functions here. For instance, we also have to say what the return type is. For instance, a float. Add. We have to specify the data type of our float. We can say return n1 plus n2. And then we can use this function inside the main function. System.out.println. That's our print in Java. And we'll say 3 plus 4 equals plus add 3 4. So between Java and Python, Java you must have a class in one way or another. You must have a main function, and you would normally declare your functions inside the classes, and they're called methods. So Java might be a difficult language to get started with compared to Python, but it gives you an idea of comparing Python to other languages, and by using Python you can get a starting point in learning these languages. I hope that'll help you kickstart your Python journey, but just it's a lot to take in, so just take things step by step. Don't do it all in one go, and just enjoy the process.